Turn your attention now to some of the most mysterious and elusive particles in the cosmos, neutrinos. These are the universe's shadow travelers, nearly massless, ghostly entities that stream through space and matter with almost no interaction. Every second, trillions of neutrinos pass through your body without a trace, invisible, intangible, yet profoundly important. Produced in enormous numbers by the Sun, distant supernovae, cosmic rays, and even the radioactive decay of atoms on Earth, neutrinos are fundamental messengers, carrying information across vast stretches of the universe, from the heart of exploding stars to the faint whispers of the early cosmos. Neutrinos are extraordinarily difficult to detect. Because they interact only via the weak nuclear force and gravity, they pass through dense matter almost entirely unhindered. Unlike electrons or protons, they rarely leave any mark. To catch even a single neutrino, scientists must build massive, sensitive detectors, often buried deep underground to shield them from other forms of radiation, or placed in the icy expanses of Antarctica. When a neutrino does interact, it produces a faint flash of light or a small release of energy, a subtle signal that must be painstakingly interpreted. Each detection is a window into processes that are otherwise invisible, events occurring millions or billions of light-years away, from the cores of stars to the most violent explosions in the universe. One of the most fascinating properties of neutrinos is their ability to oscillate between different types, or flavors, as they travel through space. Electron neutrinos, muon neutrinos, and tau neutrinos can transform into one another, a quantum trick that requires them to have a tiny but non-zero mass. This discovery challenged the standard model of particle physics and opened a door to new physics beyond what we once thought complete. It suggests that even the faintest, most ephemeral particles can reveal profound truths about the structure of reality, the evolution of the cosmos, and the mechanisms that govern matter and energy. Neutrinos also serve as cosmic messengers from the most extreme environments. From the fiery cores of the Sun to the violent explosions of supernovae, these particles escape unimpeded, carrying information that photons, the particles of light, cannot. In this way, neutrinos allow us to see the universe in a form entirely different from visible light, offering insights into stellar fusion, black holes, and the distribution of matter in the cosmos. They are, in essence, the universe whispering its secrets to those patient and clever enough to listen. Neutrinos also hold clues to some of the deepest mysteries in physics. Why does the universe contain far more matter than antimatter? How did the earliest moments of the cosmos unfold? How do the fundamental forces interplay at energies far beyond what we can produce on Earth? The subtle behaviors of neutrinos, their tiny masses, flavor oscillations, and rare interactions, provide hints that may answer these profound questions. Studying neutrinos is not just about observing elusive particles, it is about decoding the hidden instructions that shape the universe. Moreover, neutrinos challenge our perception of reality itself. They exist almost entirely outside our direct sensory experience, yet their influence is pervasive. They connect the microscopic and the cosmic, the ephemeral and the enduring, the invisible and the observable. In the study of neutrinos, we encounter a universe that is more interconnected, more subtle, and more complex than our ordinary senses suggest. They remind us that reality is not confined to what we can touch or see, but includes layers of existence that are intangible yet deeply consequential. Neutrinos are the ultimate travelers, crossing planets, stars, and galaxies without hindrance, silent witnesses to the most energetic events in the universe. They carry the history of supernovae, the dynamics of the Sun's core, and perhaps even the imprint of the universe's earliest moments. Each neutrino is a messenger, a ghostly traveler, an emissary from realms and times beyond our ordinary perception. To study them is to follow the threads of cosmic history, to perceive the universe in a way that transcends light, and to appreciate the delicate balances that allow matter, energy, and life to exist. In essence, neutrinos are both subtle and essential. They are the shadow travelers that weave through matter, bridging the gap between the observable and the hidden, the known and the mysterious. Through them, we can glimpse processes and structures far beyond our reach, understand the forces that govern the cosmos, and touch the faint whispers of creation itself. The universe's story is written not only in the stars and galaxies we can see but also in the trillions of neutrinos streaming silently through every corner of existence, revealing the unseen architecture of reality and reminding us of the profound beauty hidden in the ghostly depths of nature.